All right, welcome back to my channel. In this video, we'll be talking about the concept of Laplace transformation of derivatives. Okay, so we know normally that the Laplace transformation of f of t is equal to the integral from 0 to infinity of e raised to power minus st, then that same f of t dt. Okay, this is general form. Now we want to get the Laplace transformation of f prime of t. Let's see what we are going to have. This is going to be the integral from 0 to infinity of e raised to power minus st. Then we'll now put here f prime of t, then dt. Now, if you look at this, this is integration by parts. So if we solve this integration by parts, we will say let u be equal to that e raised to power minus st, and then dv will now be equal to f prime of t. Okay, so to differentiate this, I'm going to get du is equal to minus s e raised to power minus st. Okay, to integrate here, you now have that v is equal to what? F of t, because if you integrate the derivative of something, you get back that function. Okay, the integral of y prime of x dx is equal to just that y of x, because integration will cancel differentiation. So that is exactly what happened here. If you integrate this side, the integration will cancel this. Okay, so now you know the formula for integration by part that said that what? The integral of u dv is equal to uv minus the integral of v du. Okay, so let us now substitute everybody now. The integral of u dv, that is e raised to power minus st f prime of t dt, okay, is equal, don't forget that our integration is from 0 to infinity, is equal to, now, uv, and my uv will give us okay, uv, which is what? E raised to power minus st, then f of t. Okay, minus the integral of v du, that is minus s e raised to power minus st. Okay, minus st, then f of t. Okay, f of t dt. Don't forget that the concept is from 0 to infinity. That is the boundary. Okay, now having this is going to be e raised to power minus st f of t. Then this one coming out, I'm going to have plus s can come out as the integral of e raised to power minus st, then f of t, then dt. Okay, don't forget the concept is from 0 to infinity. Now if I evaluate this one from infinity minus 0, okay, if you put infinity here, it will now be 0. If you now put 0, it will now be f of 0, because this one will give us 1. Anything raised to power infinity is 0. So 0 times this is 0 for this particular one. Then minus, if you now put this one, so I'm going to have that this will now be, if I put infinity, okay, or let me just substitute that. If I put infinity, it's going to be e raised to power, or just understand what I'm trying to say. If I put infinity here, this is e raised to power that infinity times this. Okay, we are putting t to be infinity. So infinity times s is infinity. So e raised to power infinity will give us 0. 0 times anything is 0. Minus, when you put 0 now, anything raised to power 0 is 1. 1 times this. So what I have here is just minus f of 0. Okay, because it's this minus this. So we have 0 minus that. Or let me just write it to be, when we put infinity here, I'm having 0 minus, when we put 0, I'm going to have f of 0. When we put it to be 0, okay? Then plus s into, then from 0 to infinity here. Then e raised to power minus st f of t, then dt, okay? Now, if you remember that, this man is the same thing as this, okay? So if you remember that, watch it very well. This is the same thing as this. So I can replace this with this. So the concept now becomes that the Laplace transformation of f prime of x, of t rather, not s, of t, I hope I did not use x anywhere, of t is equal to 0 minus something is minus that. Is I have minus f f of 0, then plus, this is now the Laplace transformation of f of x, f of t, sorry. So that is that. Okay. Now, if I arrange this very well, we will now see that so there is s at the back. Don't forget there is s at the back. So this is now the Laplace transformation of f prime of t, okay, is equal to s, the Laplace transformation of f of t, then minus f of 0. So that is that for that. Okay. So proved. It's very simple. So now with this concept, it can help us to get other derivatives. So let's check what the second derivative will give us with this concept. So let me write the concept down first. The concept said that the Laplace transformation of the derivative of the first derivative of t, okay, is equal to the Laplace transformation of f of x, okay, f of t rather. Don't know why I love x. F of t then minus f of 0. Now, let us now find the second derivative. The second derivative of this will give us this is now, okay, f prime prime, differentiate this one, I have prime prime of t, okay, is equal to, now differentiate here, I'm going to have s, the Laplace transformation of f of t, okay, then minus, differentiate this one, I have f prime of 0. Okay. Now we know that from here to here, sorry, this should be prime because we are differentiating. Differentiate is prime prime, differentiate it is prime. But note that from here to here is same thing as all these things. Okay, don't forget. So we now have that this is same as saying s into, everybody here is s, the Laplace transformation of f of t, okay, then minus f of 0. All right. Now then we now have minus f prime of 0. Okay. So if you now multiply this out, I'm going to have that this is something as saying s squared, the Laplace transformation of f of t, okay, minus s f of 0, then minus f prime of 0. Okay, this is the second derivative. So tell me from this, the way the thing is moving, tell me how the third derivative will be. So L, the Laplace transformation of the third derivative of f, the third derivative of f of t, will now be the same way. So this is s squared. So it's going to start with what? S cubed, the Laplace transformation of f of t, okay? Is there any problem? Let us check where there is a problem, if there is any. Okay, yeah, there is no problem. So this is going to be f raised to power 3. Then here will now be minus s squared, f of 0. Then we'll now start differentiating. So minus s, here will now carry s f prime of 0. You will now end it with what? Minus f prime prime of 0. So that is how it's supposed to be. Okay, so tell me what this will now be. The Laplace transformation of f raised to power n of t. So what do you think it will be? It will start with what? S raised to power n. The Laplace transformation of f of t minus s raised to power n minus 1. I hope you know. F of 0. Okay, then minus s raised to power n minus 2, f prime of 0 minus s raised to power n minus 3, right? N minus 3, then I have f prime 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 of 0 minus dot dot dot. It will not end in wherever it's going to end. So let's say that the end is going to be where this will not be equal to this. So this one will be out. Okay, this will not be raised to power 0, which is 1. So I will now have minus f n of 0, right? Minus n minus 1 of 0. Okay, so that is that. So with this concept, it will not help us to find to solve differential equation with this concept. Okay, So thank you very much for this particular video. In the next video, we'll now solve differentiation. We'll now solve differential equation using Laplace transformation. Bye bye.